Hi guys, good to be back with you. Now, we've got a caller that has phoned in with a question from the Limpopo prelim. We didn't have a copy of this prelim, so we've just taken it down on the phone. So I hope we've got all the detail left. But let's have a look at what we've got so far, because it's an interesting question. And we're getting Richard on the line, and we'll speak to him in a short time. So what we're told is, Richard, good morning.
Hello.
How are you doing?
Fine, and you?
Excellent. Okay, so that what I want to recognize here is that we've got an electrolytic tank, and I think that produces aluminium. Is that right?
Yes.
So it's producing aluminium, and it's represented by the equation where we've got the bauxite, and it's reacting with oxygen to produce some oxygen plus some aluminium. Is that right?
Yes.
Okay, so what we need to recognize here, at a certain point, a current, notice that there's a very big current, and that current is applied 2,0 times 10 to the 3 amps is passed through the electric for 2 hours. It tells us...
Yes, sir. Can I correct something there?
Yeah, please do.
That first equation, it is not written
okay,
like...
Give me the right equation and I'll rewrite it.
Okay, it's 4 aluminium ions, 3 aluminium ions, 3 aluminium ions.
Okay, so they're 3 plus.
Yes.
Okay, so I'm going to write it down below, so so we get it right here. So they give you the ionic equation. I didn't see that. So it's Al3 plus, which is a aqueous. Is that right?
Yeah.
Plus yes. O2 minus. That makes more sense. Aqueous. Correct?
It's 4 L3.
Oh, okay. Got it. And then 6. Is this 6?
4 and 6 on the oxygen.
6 on the oxygen. And it's going to
yes.
produce how much?
And then it's going to produce 3O2, which is a gas.
Okay. Plus?
3O2, which is a gas.
Yes, I've got
plus
that.
Plus 4 aluminium, solid.
Okay, solid. Excellent. Okay, so now we're going to go to the table of half reactions. Do you agree?
Yes.
Okay, and on the table of half reactions, where do we start? The one that I like to use, I always get the one where I identify the lithium at the top and the fluorine at the bottom. In some papers, they call that table 4B. So I like to have my reducing agents on the right-hand side and my oxidizing agents on the left-hand side. Are you with me, Richard?
Yes.
Okay, so if I do that, I'll go to the table of half reactions and I'll find that aluminium 3 plus is on the right-hand side, so it's my reducing agent, and it produces for me aluminium plus 3 electrons. Agree?
Yes.
Now, next thing I recognize is that what I'm going to do is I'm going to start with O2 minus, and it's going to gain 2 electrons, and it's going to produce O2. So this is my oxidizing agent.
Okay.
Are you with me?
Yes,
now,
I'm with you.
if I don't know, I haven't had a look on the table to see if that one is there, but that's what it would be, okay? If it was there, but you should be able to work it out from the ionic reaction. So now, Richard, here's the important thing. If I'm losing 3 electrons and I'm only gaining 2, is that balanced?
No.
Okay, so what must I do to get it balanced?
You must multiply the top one by 2 and then the bottom one by 3.
Excellent. So I'm going to do that. 2, 2, that makes that one 6. This one by 3 makes that one 6. The electrons can cancel. Now, notice something here. This should have been a 2 in front. No, wait a minute. This should have been a 2O2, shouldn't it? Because it couldn't have just been on its own. So I need to make sure that this is now written correctly. Please forgive me for not writing that right. So if I do that, it will give me 6. Multiply by 3. It should have been 2 to start with. So it's 6, and then a 3 over there, which will be the right answer. Okay? Are you clear what I've done?
Yes.
Okay, so now here we need to recognize that what we're going to do is we're going to produce, for every 2 moles of aluminium, we're going to produce 2 moles of aluminium ions. We're going to produce 2 moles of aluminium metal. For every 6 moles of the oxide iron, we're going to produce 3 moles of oxygen. That helps me to a certain extent, in the sense that what I need to recognize is the question asked me to count the theoretical amount of aluminium. So I'm really worried about the aluminium reaction and not so much about the other one. I just want to make sure that
okay. So that one is for 7 marks.
Yes. So I'm not finished yet. I'm not finished yet, because what I need to recognize is that to get this all sorted out and to get it all nicely balanced, what I'm going to need to recognize is that 2 moles of aluminium is going to give me 6 moles of electrons. Moles of electrons. And what my equation told me is, no, you haven't got 2 moles, you've actually got 4 moles. So actually what I must work with is 12 moles of electrons. Now, the reason that is important is that I've been given a current value. I've been given a current value, and I've been given a time. So I'm going to use that, okay? Because what I'm going to do is I'm going to say Q is equal to I times T. Are you with me so far?
Yes, I'm with you.
Okay, now remember, what I'm going to do now is this is the theoretical value, the amount of charge that is flowing, or the amount of charge that is passing through the circuit. And I was told it's 2 times 10 to the power of 3 amps. And the time was given to me in 2 hours, but 2 hours isn't seconds. So I'm going to say 2 times 60 times 60. Okay? Are you with me?
Yes, I'm with you.
Right, let's clear that. And we're going to say 2 exponent 3 multiplied by 2 hours times 60 minutes times 60 seconds. This gives me my total charge, which is 144. Okay, you got that? If I change it to the engineering notation, it will give me 1,4 times 10 to the 4 times 10 to the 6. In scientific notation, that would be 1,4 times 10 to the 7. So I'm going to write it in scientific notation, which is 1,4, just check it, 4 times 10 to the 7 coulombs. Okay?
Yes.
Are you understanding where I'm going now? What I want to do is to find out the number of moles of electrons. And so that's my next step. Because in this time, that's the number, that's the charge. So I want the number of electrons. And then I'm going to actually work out the number of moles of electrons. So the number of electrons is going to be the charge divided by 1,6 times 10 to the minus 19, which is the charge on 1 electron. Okay?
Yes.
I hope you're still with me. So I'm going to take that value and I'm going to divide it by 1,6 times 10 to the minus 19. And I get 9 times 10 to the 25 So let's write that down. This is the total number of electrons, 9 times 10 to the 25. Electrons. How many moles is that?
How many?
Moles.
3 moles.
Moles of electrons.
Or how many?
How many
for
moles of
aluminium.
electrons? So if I wanted to
3
say
moles.
moles of electrons, then I'm going to say,
Or how many moles of?
correct. It's the number of electrons divided by the number in 1 mole, which is Avogadro's number. Okay? So I'm now going to
Okay.
take 9 times 10 to the 25, and I'm going to divide by 6,04 times 10 to the 23. Are you happy?
Okay.
Okay? We're not done yet, Richard. So let's just make sure that we've got this all sorted. We haven't finished our calculation. We're going to say divided by 6, 0. Now I just want to check, is it 03 or 04? Your Avogadro's number on your table should give us the standard reading. And on this table, it isn't even there. I think it's 6,03. I've written 6,04, but I think it is 6,03. You can do your calculation if it's not. It will just be out by a few factors here. So I'm getting 1,492 times 10. Sorry, I didn't do that properly. So let's just try and undo. I'll do it again. I'm going to write 9 exponent 25. Check. 9 exponent 25. Divided by 6,03 exponent 23. Okay?
Yes.
And what do I get? I get 149,25 moles. So I'm going to write that answer down. 149,25 moles. So I've got 149,25 moles. Moles of electrons. Now, here's the tricky bit. Here's the tricky bit. Richard, what we said from our equation, if we're wanting to make 4 moles of aluminium, then we've got a ratio of 12 is to 4. Do you see that? 12 is to 4. 12 moles of electrons will give you the ratio of electrons to aluminium is 12 moles to 4 moles of aluminium. So if I've got 12 moles of electrons, I've got 4 moles of aluminium. I'm going to work with that ratio because I've now got the moles of electrons. I'm going to say 12 moles of electrons is going to give me 4 moles of aluminium. So therefore, 149,25 moles of electrons is going to give me X moles of aluminium.
Okay.
Are you with me?
Yes.
Now, Richard, this is a ratio problem. And what I want you to see is it's not difficult. How did I go from 12 to 4? If the ratio is 12 to 4, what did I do to 12 to turn it into 4? I must have divided by 3.
3.
Okay.
Yes.
Are you with me?
Yeah. Me.
So how am I going to go from there to there? If I'm starting with 149,25, how am I going to get X? It must be in the same ratio. So then I must do the same thing. I must divide by 3.
Okay.
Okay? So
Yes.
this was my answer for the moles of electrons. Therefore, for aluminium, divide by 3, and I get the answer of 49,75 moles of aluminium. Okay? So we're almost done. So we're going to say from the ratio, we can say we get 49,75, was it? 49,75 moles of aluminium. Now, they might be happy with you. I just want to check what they said. Calculate the theoretical amount. Now, they should be happy with you if you give it to them in moles, but just to be safe, moles is an amount. Okay, so you could leave it there, but just to be safe, if you want to get to mass, how are you going to go from what you're going to do with the mass? How are you going to get the mass of aluminium?
We are going to use the formula M is equals to M.
You're going to say the number of moles times the molar mass, correct?
Yes.
Okay,
Yeah.
so now the number of moles is 49,75, and the molar mass, or the relative atomic mass of aluminium, if I look on the periodic table I have here, is 27. So if I put that in brackets, then I can get a gram value. So I'm going to take this, and I'm going to multiply it by 27, and I will get, this is my answer, which is 1,343, 1,343,28 grams. Okay? So we need to remember it's grams. Let's write it down. 1343. 1343, 28 grams. Now, I hope you can see, Richard, that that's just about 1,34 kilograms. It's not a lot of aluminium, is it?
Yeah.
Okay, and that's why this process is so expensive, because it needs so much energy to produce theoretically. And we will not even produce that amount because of other energy factors. So by looking at this ratio, I hope you can see that how to do the problem, but also understand that this process is actually a very expensive process. Okay, Richard?
Yes.
Okay. Have you got any more questions on this, or do you follow exactly what to do?
Yes, I've followed it.
Okay, now I want to give you a hint. Instead of just following it now, please make sure you go and try it again for yourself so you can see exactly what we've done. We've looked at the half reactions, we've looked at the ratios, we've calculated the number of electrons, and we've done a ratio calculation. Okay, Richard, I wish you all the very best. Remember that if you've got any more questions, we're going to be back just before the exams. We're going to be going over both paper 1 and paper 2 questions in the week of your exam. So look out for us and send us your questions to that email address, to helpdesk@learnextra.co.za, or during the week, if you've got a question, please phone us at 086 1058 262. It will go to a voice prompt, and you can leave it with us, and we will get back to you. Leave us an email address so that we can answer it. Of course, you can also post on Facebook. That's at www.facebook.com/learnextra with an X. Okay, we're going to do a short break. After that, we'll be back with our final question for today, and we'll see you then.